So in our previous video, we saw that these three lines are the lines that are associated with our three equations for our system of equations, for our constrained optimization problem, ooh, that's a mouthful, for Otto and his toy cars and trucks. And we used slope-intercept form, y equals mx plus b, to find these three lines, and then we let Desmos clear it up for us. So let's take a look at this system of equations. Well, I see that we have some intersections on our graph here. Our line for our wheels and our seats intersects here at the point 3, 4. The line for our wheels and our gas tanks, the line for our wheels and our gas tanks intersects at 3, 4. The line for our wheels and our seats intersects at 6, 2. And then we have an intersection between our seats and our gas tanks over here at what looks like 5 1/3 and 3 1/2, something close to that. But what's really interesting to me is that we have our intersections at two valid combos, 3 cars and 4 trucks, 6 cars and 2 trucks. And what's even more interesting to me is that these intersections align with those previous optimal solution points that we found in previous videos. I'll tell you, that's no coincidence. Our system of equations intersections provide us with the optimal solutions that we need to check in order to determine the maximum profit for Otto Toyom's toy enterprise. So we know because of our intersections, 6, 2 and 3, 4 are points that we need to check, but they're not the only points that we need to check. Since we're trying to maximize our profit, we need to look for the smallest y-intercept, and that's 0 cars and 5 trucks. Since we're trying to maximize profit, we need to look for our smallest x-intercept, and that's 7 cars and 0 trucks. And then lastly, we need to check 0 cars and 0 trucks. And every time we solve one of these constrained optimization problems, we need to test the point 0, 0. We need to test our smallest y-intercept, our smallest x-intercept, and wherever our lines intersect each other, like within this region. Before, we had 32 points that we needed to check. And in order to find the maximum profit, we had to do a lot of mental math, or math on our paper, on a lot of these points in order to find out where our maximum profit occurs. That's a weird way of pronouncing that. Occurs in each of our scenarios. I'm going to erase this because it's not helpful for us. Now, instead, we just have 5 points to check instead of our 32. And we're going to develop an equation that's going to help us to do that work much more easily than we were doing it previously. So take your notes on this if you have not already copied them along with me. And let's move together into the next video where we talk about finding the maximum profit based off of the candidate points that our system of equations provided to us. I'll see you in the next one.